know the tidal force wrought upon Earth by the moon has nothing to do with the phase of the moon?
It doesn't?
It's the same all the time.
It's the same all the time.
A full moon
Has the same amount
has
of
the
gravity.
same tidal force on the Earth and on you as a quarter moon, as a half moon, as a, whatever, all those phases.
So the tidal force that we know the tide shifts. Like, what is it? Gravity alone that's causing that tide to shift?
The tide actually doesn't shift.
It doesn't.
No.
What happens?
No. Okay. So wherever the moon is in space, the side of Earth closest to the moon is more attracted to the moon than the side that's farthest away. Okay. So because the total force is different across Earth, Earth gets stretched a little, elongated. It's especially visible in the oceans relative to the land, but Earth's physical body is also stretched in a direction towards the moon, except it's a little ahead of it, but we don't have to worry about that for the moment. So the moon stretches the tide. That's called the tidal force on the Earth. Okay, so now watch. As Earth rotates, we rotate once a day. How long does it take the moon to go around the Earth? Once a month. So here's this tidal bulge. Earth rotates inside the bulge. And what you say at the beach, oh, the tide is coming in and out. No, it is you rotating into and out of a tidal bulge that's fixed in space towards the moon. Our language doesn't reflect reality. We say the tide comes in and out, but we are rotating into the bulge and then out of the bulge. That's why there are 2 high tides in a day.
Oh.
And then into the other bulge, which is on the other side, and then out of the bulge. 2 high tides, 2 low tides. All right, so now, why are high tides higher during full moon?
Why?
Because the sun also makes tides on Earth.
Oh my goodness.
About 1/3 the strength of the moon tides. And there's the sun tides trying to blend in with the moon tides, and it's on a different cycle, okay? And, when we have full moon, the sun is creating tides that are added to the moon's tides. So we have higher tides on the full moon because the sun's tides add to it. Not because the moon has any special extra powers over us. So it is uninformed and in some cases just outright BS that people are saying the full moon has extra power and tides over you. No, it doesn't. The moon itself, no.
Now people are 60 whatever percent water.
Mm-hmm.
What percent are we?
It's about that. That's fine.
So if
more than half, yeah.
If the moon affects the tides, wouldn't it affect the water in your body?
Yeah. So the tidal force is the force across the size of the object.
Right.
Okay. So Earth is 8,000 miles across. So the gravity from the moon is somewhat less on the far side of the Earth compared to the side of the Earth nearest the moon. So you have to ask, how much stronger is the moon's gravity from one side of your head to the other?
So
that's the question.
Right. It would have to be pulling you in a certain direction.
No, it had to be stronger on one side than the other and have to stretch your head. We can calculate how much that is. And I did it once. It was something like 1/millionth the force that's operating on your head from the weight of your pillow. Science has worked since basically the year 1600, where Galileo sort of starts codifying what people knew probably should be happening, but no one really did it in large scale. If you have an idea about something, then you test it multiple ways and get other people to test it. And if the tests give you consistent results, you have a new understanding of the universe. When that happens, that knowledge of the universe doesn't go away. It doesn't get undone. What happens typically is you have a deeper understanding of the universe in which that understanding gets embedded. And you realize that you only understood a small part of a larger whole. But the small parts you did understand, where you had multiple experiments that confirmed it, that doesn't change. So the cleanest example of this is Newton's laws of motion and gravity. Did anyone see anything move faster than a galloping horse in his day? Probably not. And so the Newton's laws of motion and gravity worked. They worked not only for galloping horses, it worked for the moon in orbit around the Earth, and the Earth in orbit around the sun, and Jupiter's moons in orbit around Jupiter, all right, and for the planets. So, okay, but wait a minute, it doesn't work for Mercury. Mercury's orbit is not following Newton's laws. Is there something wrong with the data? Let's check it. Data's correct. Oh my gosh, what's happening? Einstein comes along and says, I have a new understanding of gravity and a new understanding of motion. And it accounts for this weirdness in Mercury's orbit.
What was the weirdness?
Its shape was not exactly what Newton's laws of gravity would give you. Its shape could only be accounted for when you throw in Einstein's theory of general relativity. Why? Because the sun's gravity is so monstrous and Mercury's orbiting close enough to it that it's being influenced by extra phenomenon going on in the universe that's the product of very high and significant gravity. And so then do we throw Newton out the window? No, actually. You know what Newton's laws are? They're what Einstein's laws look like when you put in low speeds and low gravity. If you put in low speeds, they become Newton's laws. In that limit, Newton's laws don't stop working where they used to work. Apollo to the moon used only Newton's laws because Einstein didn't matter at those scales. The moon and Earth and rockets, we're not going fast enough for any of that to matter. But when you start going fast enough, you cannot use Newton's laws. You have to use a deeper understanding. Now, where does Einstein take us? You go into the center of a black hole, you get black holes from Einstein. Center of black hole is a singularity. All the theories say the matter occupies zero volume, thereby having infinite density. And that's kind of weird. What? No, you can't have infinite. No. That's a limit of Einstein's theory. That's where it breaks down. Some have joked that's where God divides by zero. Remember in math class, you can't divide by zero.
Right.
It's not defined or not allowed. So in Einstein's equations, we're dividing by zero at the singularity. So we all know that as brilliant as Einstein was, and as successful as his general theory of relativity has been, it has limits. And one limit is the center of a black hole, and another limit is the very birth of the universe itself. Getting back to your question, the Big Bang. So we have top people working on trying to resolve this singularity problem. And in so doing, you get to some ideas that, well, maybe our Big Bang, because the Big Bang is not going to go away. All the data support this. So now I've got this Big Bang thing, okay? And, well, is this embedded in something bigger? Ooh. So when you put like quantum physics and general relativity and you try to come up with some bigger understanding, deeper understanding, string theorists have been all into this, you get a multiverse. We didn't pull that out of our ass. That came out of the equations. So how old is the multiverse? I don't know. It's definitely older than our universe because it birthed our universe and it births other universes and it births, the way the equations drive it, an infinity of universes. This is the idea that maybe there's a version of us in another where I'm bald and you got the afro but everything else is the same.
And also a version where everything's the same.
Where everything would be the same, yes.
Everything you've ever said has been said before exactly in the same order.
Correct. There's no reason to presume that everything in this universe isn't or hasn't already played out in the exact way in another one of these infinite universes.
And in an infinite number of different ways.
Correct. And so that is what comes out of the equations. So that makes the Big Bang a kind of a small part of a much larger whole. And so, yeah, we're ready for that. But the fact that the universe had a beginning 14 billion years ago, and there's the cosmic microwave background, all of these features are intact. They're not going to all of a sudden not apply. That's my point.